Hey guys, welcome to day 4. This is Monday, March 23rd, 2020. All right, something you guys are already familiar with is scientific notation. Just like we use metric prefixes to describe really big and really small numbers, scientific notation does exactly the same thing. So, a couple things when looking at a number. Whatever comes in front of the 10 is called the coefficient. And the number that is a superscript that comes after the 10 is called the exponent. Now, a couple things. The coefficient. If we have a positive coefficient, that indicates that we have a positive number. If we have a negative coefficient, that indicates that we have a negative number, okay? Now, we can also have positive and negative exponents. I'm going to keep this simple. If you have a positive exponent, in this case, it's positive 5. This indicates a big number, okay? So 250,000, okay, is a big number. That exponent can also be a negative number, and a negative exponent indicates a small value, a decimal value. So per se, if this was 10 to the negative 5, it would be 0.000025, but it's not, okay? So a positive exponent represents a big number, and a negative exponent indicates a small number, usually expressed in decimal value, okay? All right, so we've talked about coefficients and exponents. One other thing, guys, kind of trivial. Sometimes we will say 10 to the 0. 10 to the 0 is equal to 1. I've also attached a Khan Academy video for you, so if you do want a little bit more in-depth explanation, feel free to go watch it. I think it's about 12 minutes long. All right, now what we have to do here is we have to look at an exponent and we have to be able to convert it into an ordinary number. So we have 5.4 times 10 to the 3. Okay, so 5.4 is a positive number. 3 is a positive number, so it means we have a big positive number. So you can think of this as a couple of different ways. You can think of the 10 to the 3 as 10 times 10 times 10, or 3 sets of 10s. Or you can think of it as being a 1 with 3 zeros behind it. So if you look at it this way, 1,000. So that is a 1 with 3 zeros behind it. Regardless of how you want to treat it, 5.4 times 10 to the third is equal to 5,400. So 10 to the third means that you're going to shift that decimal 3 positions to the right, and your understood decimal would fall after the final 0. Now let's look at one with a negative exponent. Okay, we can think of this as 5.4 times 10 to the negative 3, or we could do 5.4 divide by 10, divide by 10, divide by 10, or you can think of it as divide by 1,000. Regardless of how you think about it, if we have a negative exponent, we are going to shift that decimal 3 positions to the left, in which case it would be 0.0054. Remember, guys, I put a space there just for grouping purposes. All right, now some examples. All right, we have to convert these to scientific notation. There is an understood decimal there, and we have to move that decimal 4 places to the right. Proper scientific notation means 1 digit to the left of the decimal. So my coefficient is going to be 3.6, and because I moved it 4 positions to the left, I'm going to call it 10 to the 4th. This is a big positive number. Okay. All right, now we have a negative number. A negative number is indicated with a negative coefficient. Now, proper scientific notation says we want that decimal between the 6 and the 7. So I'm going to call it 6.7821. And in order to do that, I had to move that understood decimal 7 positions to the right. So the exponent's going to be 10 to the 7. Remember, a big number is a positive exponent. So we've got a negative coefficient and a positive exponent, okay? Whoops, sorry about that. All right, next example, a small number, okay? We want to put the decimal after the first non-zero digit, so I'm going to call it 8.1. I had to move the decimal 3 places to the right, so I'm going to call it 10 to the negative 3. Remember, a negative exponent means a small number. I think there's supposed to be an understood decimal here, but we want to put it between the 3 and the 2. Proper says we only want to have 1 digit to the left. I have to move it 3, 6, 9, 12, 13 places to the right, so I'm going to call it 10 to the negative 13. And the last one, the decimal is already in the right place, but if I want to put it in scientific notation, remember, 10 to the 0 is equal to 1. So it's 7.3 times 1. Now the other direction. Let's go from scientific to ordinary numbers. Now a big number means that we're going to move that decimal 5 places to the right. So it used to be between the 6 and the 3, and now I moved it 5 places to the right, and I'm going to put a comma in there. So the decimal used to be here, and now it's here, 5 positions to the right. That's 630,000. All right, 6.02 times 10 to the 23. I have to move that decimal 23 positions to the right. So 602 3, 6, 9, 12, 14, 18, 20, 21 positions. Nope, that's not right. All right, let's forget about that example. Move to the next one. Regardless, guys, that's going to be a really big number. All right. 9 times 10 to the negative 3. Remember, a negative 3 indicates a small number, so we're going to move that understood decimal 3 positions to the left. So 0.009. A negative exponent means I'm going to have to shift the decimal 4 places to the left. 0.0004444. Okay, 10 to the 0, remember, is just 1. So negative 5.7 times 1 is just negative 5.7. Now this one, we have the decimal between the 7 and the 8. And in proper scientific notation, we should only have 1 digit to the left. So I'm going to move the decimal 2 places to the left. And when I do that, my exponent's going to grow by a factor of 2. So although this is in scientific notation, it's not correct unless I get that decimal between the 5 and the 6. Remember, guys, if you have any questions, you can leave a comment on Google Classroom. You can email me directly. Stay safe, stay healthy. I love you guys. I'll see you soon.